Okay, we are going to talk about the difference. There's a difference between theoretical and experimental probability. I don't know if you learned about this in the younger years, may have, but here it is again. So experimental probability, I'm going to use two different highlighters here. Experimental probability is based on trials, right? Based on trials, experiments, or surveys. Can't do a thing these days without them wanting to know how it went, right? You buy anything online, it's like, hey, let us know how the purchase was. Like, it's just like a $2 Sharpie, leave me alone, right? But they want to know. And so that is what the difference is here. It's when it comes to experimental probability, I will always use EP when I'm specifically talking about experimental. And so the total number of trials will go in the denominator. How many times did you try this? How many times did you roll the dice, right? Versus the other side, the theoretical, that's what we've been doing a lot. We actually have been doing both of these. I just didn't ask you what the difference is. Okay, so it's based on possible outcomes. Okay, and so here it is, number of possible outcomes. So how many outcomes are possible? How many ways can the die land? 6 times. There's 6 options there. So the top is still the same, like how many times did it actually occur, but the denominator will be different. So keep an eye on that. And look at what I put at the bottom here. How can you notice the difference? So let's look at experimental probability. The likelihood of someone having a certain blood type, that is based on actual experiments. Like they keep track of that, right? The likelihood of a team winning a game, that's based on how has that team done in the past, right? The likelihood of someone voting for a certain candidate, if there's 3 candidates, in theory it's 30%, 33 for each candidate, right? But it's not. If you poll the people, they'll tell you which one they're leaning towards, right? So that you would want to do an experiment on that. Theoretical, it's asking what's the likelihood of someone drawing an ace, for example. Well, we would not base it on experiments. We would just look how many aces are there and how many cards do we have, and that's how we come up with our probability. The likelihood of rolling a 5. When you spin a spinner, we're basing it on theory, right? What is there? So follow me, please. Here, very important concepts before we do some math. In general, when we perform experiments involving events, there's no bias. Where there's no bias, right? The EP should be similar or equal to the TP, right? Experimental probability should be the same as the theoretical. Make sure you follow. The main reason they may be different is because there's a small sample space. What is a small sample space? Let me try this. It doesn't always work, but maybe Victor. Are you a Jets fan, Victor? Are you a Jets fan? Winnipeg Jets fan? No. Ashley, are you a Winnipeg Jets fan? No. So
I know how they play.
Yeah. So I'm just asking 2 people, and I determined that nobody's a Jets fan at Sisler. I just used 2 people. They answered no and no. So 0%. Terrible sample space, right? You need more people. Even if I just ask this class, still not good enough to make a decision based on Sisler in general, right? You'd have to ask more people. Same with that. If you roll the die once, okay, you got a 4, got a 5, right? And let's say you roll again, you get a 4 on your 3rd roll. It's like, hey, 2 out of the 3 rolls were 4, so obviously 66.67% of the time you get a 4. It's not true, right? You need to roll like 50 times, 100 times, maybe 200 times for you to find out that each number has a 1 out of 6 chance to be rolled, right? And so small sample space is why those probabilities are different. I'm going to box in this whole thing here. Small sample space, experimental does not equal theoretical, but if you have a large sample space, then they are similar or the same. Maybe highlight this. Okay. When making a, and then watch what I say here, the note. I put this just before I was about to print this booklet, right? When making a prediction and you know both probabilities, we use the theoretical probability to make a prediction. We do not base it on the experiment, okay? So when you make a prediction, you base it on the theoretical, not the experimental probability. So let's go through an activity, and you're going to have to answer 2 questions at the end to see if you understand it or not. Page 28. Look at that bag. I drew that by hand with a mouse. So it's a pretty nice bag, eh? A bag contains various letter tiles as shown as seen below. So this is my bag, right? Alex draws a tile, records the results, then places the tile back in the bag. This process is repeated 8 times. Process is repeated 8 times. I would highlight that. And write big in there, 8 trials. Okay, we're going to circle that. 8 experiments are being made here. Here are the results. So you've got, right, these are what the letters that he was drawing and he recorded them, right? So I will also do this. 8 trials. One more time. I just really want to drive that point home today. State the experimental probability, it's highlighted, or it's underlined, I should say, of drawing a letter A. So I'm going to, in this case, you want to make sure you distinguish between the 2 probabilities. So I'm going to go experimental probability of drawing an A would be, I performed 8 trials. I do not care how many are in this bag. Count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 in here. I don't care about that when it comes to experimental probability. I base it on what actually happened. 8 trials, and let's count how many A's we got. 1, 2, and 3. So 3 A's drawn. Okay. 3 A's were drawn. So that's 3 over 8. That is 0.375. And that's 37.5%. Okay. So that's the experimental probability. Now, it's asking state the theoretical probability of drawing the letter A. So we go TP. And here I'm going to change my strategy. My attention is on the bag. There's 10 tiles. Right? 10 tiles are available here. So I will put 10 possible outcomes. You know what? I'm going to put outcomes underneath. Sorry. I want my space there. 10 possible outcomes. And how many A's are there in this bag? So there are 3 as well, right? So that happens to be the same. That's just coincidence, right? So 3 A's in bag. Okay, make sure you write that there. So that would be 3 out of 10. I don't think we need a calculator for this one. We know that's 0.3, which is 30%. and you can clearly tell that they're not matching. The percentages are not matching. And so here's our here's what we're going to explain that. Now, why is the experimental probability different than the theoretical probability? Okay, why are they not the same? Why are they not even close? It's quite a bit of difference there. Okay, and we would just have to say it's due to the low number of trials, right? This is due to the low number of trials performed. Okay. How could you solve this? Alex would have to repeat the trials 50 or 100 times so that the experimental probability would be similar or equal to the theoretical probability. And you know what? I don't worry so much about the actual number of trials. Just mention that you need to increase it, right? I'll put that in bracket here. Increase sample size. When they draw blood to do a test on you, right? They need to draw a significant amount. They can't just go with a drop, right? And the reason being is that they actually often they run it multiple times just to make sure they get it right. And one more, and then I'll ask you to answer some questions on your own. If Alex would draw 500 tiles, how many times would you expect to draw the letter A? So you're making a prediction. Prediction. We would use the theoretical probability times 500. And that equals, in this case, it's exactly 150 times. And watch this. I will make an arrow there and say, use theoretical probability, exclamation mark, exclamation mark, exclamation mark. Just keep going until you're tired. So do not use the 3/8, right? When you have a choice between the two, you go with theoretical, okay? You go with theoretical. I'm not done yet. I want to make sure you understand. See, I got it already. So I'm going to take these 10, this 10 here, and just make sure you understand. I based it. That came from the number of tiles in the bag, right? Like how many options are there? How many sides does this die have, right? 6 sometimes 12, sometimes 4. In this case, there are 10 letters available to me. Whereas the experimental probability came from the number of trials. Okay? So make that arrow there. They were taken from different places, right? I should have had an example where I don't have 3 for both of them. Now in retrospect, I'm like, but it just happens that there were 3 here. Let me see. I will try this. Okay. 3 A's. there, that's where these came from. And orange, right? These 3 A's here gave me that one there. Okay. There's one more thing that I'm just thinking of it now to help you out. This is just to help you out. And you love writing stuff down, right? So it's win-win. Next page, or previous page. Just back to these 2 boxes here. Think of it this way. I don't want you to use it to explain. Maybe you can throw it in there, but this is based on what happened, right? The experimental probability is based on what happened, right? Where this is more like what should happen. The first one is based on what actually happened. This one is what should happen in theory. I will say this, in the long run. In the long run, this is what technically should happen. It's not like it should happen, like we hope so. No. In the long run, if you kept on doing that experiment, you should get this. Okay. All right. And remember the prediction thing down here? Only if you have to choose between if you have them both, choose theoretical to make your prediction. If you only have the experimental, then that's all you have to go with. Okay. So let's go to page 28 again. And I would like you to try the rest of 28. I'm gonna correct this in a bit. I'm just gonna give you a couple minutes, but you can already start working through the other pages. I made some decent questions there for you to try this, what we're doing today. And remember, it's asking you to write the odds in favor and odds against as well for that particular question. So try both of these. Just try it, even if you get it wrong. Today is not a big deal, right? You gave it a go. I'm gonna keep working because I'm gonna post all the pages following this. So state the experimental probability of drawing a letter B. So the experimental probability of B, again, Alex made 8 trials. And if you go up there and you count how many B's, there's only 1. Okay. So that's your answer. We don't need to state it as a decimal, but why not? We want the odds in favor of that happening. So you would have 1, 2, you take the denominator, subtract 1 from it, so it'll be 1 to 7 will be the odds of that happening. The theoretical probability of drawing a B, we have 10 now, guys, right? Now it's theoretical, now it's based on what's in the bag. And how many B's are in there? I'm gonna go count. 1, 2, right? 2 of them. So that's 2 over 10, which is 0.2, which is 20%. And it's significantly different, right? State the odds against this happening. So that means that I will have B here, not B there. So there are 2 B's, and this will be 10 minus 2, so this would be 8 to 2. So basically I'm just using the total here, subtracting what I put down before, and coming up with the 8 to 2. And I know this might seem a little outrageous to you, but you don't need to do every single one. I'm going to post pages 28 to 38. And you do as much as you need to understand this concept. Okay. Some of these questions you will realize, oh, I saw this in the homework. If you do your homework, you're going to see stuff like that on the ACs that are coming up. Okay. So that's it for me today. This is now you time.